Okay, so hello everyone. My name is Prayas, and now I'm going to explain you about EDM, like what is EDM, how it works, its advantages, disadvantages, something like this. And you can also call it a small PPT presentation on EDM, and you can also add your points from my PPT that it will help you in your presentation of EDM. So starting, what is introduction? Introduction to EDM. EDM stands for electrical discharge machine. It is an electrothermal, non-traditional and unconventional machining method. What is electrothermal? I will explain you on the next slide. In next slide. And now non-traditional and unconventional machining. I made a mistake that I wrote non-conventional, but that is unconventional. There is no word in this world like non-conventional. It is unconventional. UN. So non-traditional and unconventional machining methods are those machines in which the workpiece and the electrode or tool are not in contact with each other, like this EDM machine. But traditional and conventional machine methods are those machines in which in which the workpiece and the cutting tool both are in connect with each other, like lathe machine, CNC machine, or milling machines. These are. Now the process is also called as electro discharge machining or electro spark machining. I will explain this in the next slide. Here electrical energy is used to generate an electrical spark, and material removal mainly occurs due to the thermal energy of the spark. Now the main point of EDM, that it records the MRR, that is material removal rate of different materials by applying a high frequency through the electrode to the workpiece. In EDM there is a dielectric fluid also used as an insulator. This is our EDM machine. In our university this one is there. Now next slide. Working principle of EDM. It is called as EDM or spark machining or spark eroding. Why it is called as spark eroding? Because using the spark it removes the material, so it is called as spark eroding, and it is based on thermal electrical energy. Why it is thermal electrical energy? Using the electrical energy it creates the spark, and with the help of the thermal energy of the spark it removes the material, so it is called as thermal electrical energy. And we know that in a DC supply the negative end or cathode end connects to the electrode, or the positive end on the anode end connects to the workpiece. So and we know that the opposite charges attracts each other. And now the dielectric fluid. A dielectric fluid that now initially used as an insulator, after a certain voltage or a high voltage it becomes ionized and breaks into positive and negative ions, and the both ions, that the positive and negative ions, in between the gap of electrode and workpiece, it creates an envelope and helps to create sparks, and that sparks generally produced amount of 8000 to 12000 degrees Celsius, that melts the material from the workpiece and removes it. And here is the gap between that electrode and the workpiece, and here it creates an envelope that removes the material. Next slide. Here important parameters of EDM, that what are the important parameters in EDM we are using. Two types, that one is input parameter, another one is output parameter. In input parameter, this is spark on time, spark off time, voltage, discharge current, and arc gap is there, and also there are many more, but I mentioned there these 5. First, spark on time, the T on. This is the duration of time that the current is allowed to flow per cycle. Per cycle the amount of current is flow. The spark off time, T off, is the duration of time in between the sparks are generated. Now voltage, and we know that the potential difference is called as voltage. It is the potential difference between the electrode and the workpiece that can be measured in volt. And discharge current is, it is the current flowing through the electrode and is measured in amperes. Voltage in volt, current in amperes, we know that. Arc gap is, it is the distance between the workpiece and the electrode during the process of EDM. I previously show you that this is the arc gap, the distance between the electrode and the workpiece. Now output parameters. In output parameter we have two output parameter. One is the MRR, that is material removal rate. Another one is surface roughness. And how the MRR is calculated. The MRR is expressed as the ratio of the difference of weight of the workpiece before and after machining to the machining time and the density of the material. Now surface roughness. What is surface roughness? Surface roughness, how it is calculated? It is calculated by a profile meter, or called as tally surf, which is used to measure the machine surface roughness. The smaller RA value, what is RA? RA is belongs to surface roughness. The smaller the RA value indicates better machining performance of EDM, and vice versa. Next slide. Now it is the advantages and disadvantages of EDM. First, advantages. Fine holes can be easily drilled in EDM. Even harder materials can be machined. It creates a very complex shapes very easily. In EDM, dimensional accuracy is very high than the conventional machines like lathe and milling. Any material which is electrically conductor that can be machined easily. I hope you all understand. Now disadvantages. The material removal rate is very low in EDM. Yeah, that if you had already worked on EDM, then you know that it's very slow process, and the gap between the electrode and the workpiece is not easily predictable, especially in case of complex geometries. That the arc gap I told in the previous slide, that is not easily predictable. Last point is, it takes more time for operation than conventional machines. I already told about this. The next slide here, it is a experiment that we have done in our EDM machine. And so that's all for now. I'm going to close it. Bye bye, goodbye everyone.